And welcome to another episode of 3-Minute Videos with Nathaniel. Today we'll now solve a huge question. Question 2 of MAT, Oxford 2015. Suppose we have two functions ax and bx. Now part 1 asks us to find a relationship between them. Let's try a, b, x. This means that you have to start with bx and then you have to apply ax on this, which becomes this, equals to 6x plus 4 plus 1 equals to 6x plus 5. Interesting function, right? Now how about b, a, x equals to 3, 2x plus 1 plus 2 equals to 6x plus 3 plus 2 equals to 6x plus 5. What's happening here? A, B, and B, A are the exact same thing. So that means we can switch the order of A's and B's whatever we like. Now, let's look at part 2. Part 2 asks us to find an expression for A, x, and then you put lots of brackets here, and where the A is repeated n times. So, we denote this as a to the nx. a1x equals to ax equals to 2x plus 1. a2x equals to 2 times 2x plus 1 plus 1 equals to 4x plus 3. A cubed x equals to 4x plus 3 plus 1 equals to 8x plus 7. Hey, would you look at that? The x coefficients are the powers on 2 and the right side are the machine numbers directly below that. By the way, a machine number is a form of 2 to the power n minus 1. So we can write a to the power n x equals to 2 to the power n, which is the power of 2, plus 2 to the power n minus 1, which is the nth machine number. Now, the question asks us to put a sequence of A's and B's together to create 108x plus c. How are we going to do that? Let's factorize 108. You might know 108 is 9 times 12. 9 is 3 times 3. 12 is 3 times 4. And 4 is 2 times 2. This is what is called prime factorization. So you need 2 A's and 3 B's. That's interesting, right? So how many ways this can be done? Well, it's easy, using combinations. Now, we have 5 items here. We need to divide it by 3 factorial, which is how many ways you can arrange 3 objects, because this is the same. Same goes with the 2 objects. Now, 5 factorial is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. Notice we can cross out the 3 times 2 times 1 equals to 5 times 4 over 2 times 1 equals to 5 times 2 equals to 10. Now, imagine, we are now doing part 4 of the question. Imagine a drunkard who is only allowed to walk up and right across, say, this way. Because you see, we have, this is the bx direction, and this is the ax direction. So the drunkard needs to get from this point to this point. In how many ways this can be done? Obviously, the answer is 10. But what about, let's say we pick a random path, say this. Now we realize that ABX is BAX, so we can actually switch the direction on the humps. So it becomes this, then this becomes this, and then this becomes this. So we effectively reduce any path up to this straight path. So what is C? We have shown that C can only take one value, and that is 0 times 2 plus 1 times 2 plus 1 times 3 plus 2 times 3 plus 2 times 3 plus 2. this turns out to have a value of 107. The question now asks for a sum of this function. Dot, 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 and then it goes on forever. So we have found out that a and b and x, this has 2m 3nx plus 2m3n minus 1. We have seen that. Now we're going to add all the functions together, which will make k of these. Suppose that there are k functions in a line. Is that right? Yes, there is. Now the question asks to find the value of 214x plus 92. Is it constructible? Certainly not. Because if we see 214 minus 92, which we hope is the number of terms, is 122. Which means you'll need 122 terms to see this. We can see that this can't be done because most of the terms will only require a's and b's. And besides that, it is completely illogical to have no instances of a and b on x. It will just equal x. So anyway, thank you for this quick digression on adding functions and some commutativity. And this is a rather special set of functions, a, b, x, and b, a, x, which are very interesting functions because I think that they are called commutative functions because the commutative law of addition on any multiplication, it means that it's the same one order as applied to the other. The same goes for a, b, x. Now, and imagine this random walk of a drunkard. You can extend this to 4 directions, though I doubt this will have any value. And we have shown that this principle of commutativity between these two functions can let us reduce any path to this 108x plus c will reduce to the simplest and shortest path. Thank you! Bye!